I remember this one afternoon, not too long ago, lying on a soft patch of grass in a park just outside of Austin, Texas. The sun was warm on my face, the kind of gentle warmth that makes you feel lazy and happy all at once. My daughter was chasing a bright yellow butterfly nearby, her laughter echoing in the wide open space. I looked up past the wispy white clouds that drifted by like cotton candy puffs and just stared at the sky. It was this incredible, deep, and endless shade of blue. It wasn't just blue, it was 100 different blues, from a pale, almost whitish hue near the horizon to a rich, royal blue directly overhead. It was so vast and perfect, it almost felt like you could fall right into it. Have you ever had one of those moments where you just stop everything you're doing and look up? It's something we see almost every single day, but we rarely take a moment to truly appreciate it, or better yet, to ask why. Why that specific color? Why isn't the sky green or yellow or maybe even a fabulous shade of sparkly purple? I mean, purple would be pretty cool, right? As I lay there, watching my daughter finally give up on the butterfly and plop down beside me to look for shapes in the clouds, that simple question started buzzing in my head. Why is the sky blue? It's a question kids ask all the time, and the answer is one of the most amazing bits of science you'll ever hear. The story of our blue sky isn't just about a color. It's a story about light, air, and a wild journey that begins 93 million miles away on the surface of the sun. It's a cosmic light show that plays out for us every single sunny day. So, let's put on our science explorer hats. We're going to unravel this beautiful blue mystery, and by the end, you'll never look at that big, beautiful sky the same way again. First things first, we need to talk about the main character in our story, sunlight. When we look at the sun, which you should never, ever do directly, by the way, always use special glasses. The light it sends our way looks white, or maybe a little yellowish. But that white light is actually a super secret imposter. It's not one color at all. It's a mixture of all the colors of the rainbow, all blended together. Think of paint. Mix all the colors and you get a murky brown or black. With light, it's the opposite. Mix them all and you get brilliant white. How do we know? The most beautiful clue is a rainbow. Tiny raindrops act like prisms, bending white sunlight and splitting it into individual colors. Suddenly, you can see them all in order: red, orange, yellow, green, blue, indigo, violet. That rainbow proves sunlight is a team of colors traveling together. The visible light spectrum. Each color is a different kind of wave. Some are long and lazy, like red and orange. Others are short and energetic, like blue and violet. All these waves travel straight from the sun to earth, mixed to look white, crossing the vast emptiness ready for their big moment. Understanding that sunlight is many colors, each with its own size and energy, is the key to why our sky has any color at all. If sunlight were only one color, our sky would look very different. It's this beautiful mix of long reds and short blues that sets the stage. Next time you see a white glint, remember, a whole rainbow is hiding inside. Now that we know sunlight is a secret rainbow, let's talk about the second major player, the atmosphere. You can't see it, you can't really grab it, but it's all around you. A giant invisible blanket of air surrounding our planet. It's mostly nitrogen and oxygen, along with tiny bits of dust, pollen, and water droplets floating around. This blanket gives us oxygen, protects us from harmful rays, and keeps Earth at a nice, cozy temperature. For 93 million miles, sunlight's trip is smooth. Then it hits the atmosphere, like an empty highway turning into rush hour. On the moon, with almost no atmosphere, the sky is black even with the sun shining. Light travels straight to your eyes with nothing in the way. Our atmosphere is a stage where light and air dance, a filter, a shield, and a prism all rolled into one. It's thick enough to interact with light in a very specific way, yet transparent enough to see space beyond. When the sun's high, light travels through less air. Near sunset, it travels through much more. and that changes the colors we see. This journey gives us our blue daytime sky and those spectacular reds and oranges at sunset. And the reason is a phenomenon called scattering, the secret behind that brilliant blue. Think of sunlight playing a massive game of pinball across our atmosphere. Ready to see how the blue balls rack up the high score? We've got sunlight, a mix of rainbow waves, and the atmosphere, a big blanket of air molecules. Now, let's bring them together. When sunlight enters the atmosphere, it bumps into tiny gas and dust particles. The light doesn't pass cleanly, it gets scattered. Imagine throwing marbles on a smooth floor, straight lines. Cover the floor with bouncy balls. Chaos. That's sunlight in our air. A wave hits a molecule, gets absorbed for a blink, then re-emitted in a new, random direction. It's called Rayleigh scattering. Here's the crucial part. Not all colors scatter equally. The size of the wave matters a lot. Air molecules are much smaller than visible wavelengths, but just the right size to mess with the shorter ones. Long, lazy red waves cruise by, barely noticing. Short, energetic blue waves? Different story. They get bumped and scattered. It's like driving a smart car through a field of big yoga balls. You'll bounce in every direction. Blue light is that smart car. Blue light hits gas molecules and scatters everywhere, up, down, left, right, and all around. From the ground, sunlight's reds, oranges, yellows mostly travel straight from the sun to your eyes. But blue light is arriving from all directions. It's as if the entire atmosphere becomes a giant, blue-colored light bulb, filling the sky with soft blue from everywhere. That scattered blue light fills shadows and softens contrast. Our sky acts like a giant photographer's softbox. On the moon, it's blinding sun or pitch-black shade. On Earth, it's gentle and bright. Picture a dark room with a white spotlight. Fill it with fine, blue-tinted dust. The beam still hits the floor, but the whole room glows blue. Our air molecules do the same thing with sunlight. Now, you might be thinking, wait a minute, Emily. You said short waves scatter the most. Violet is shorter than blue. So why isn't the sky violet? Excellent question. Gold star for paying attention. First, the sun doesn't send all colors equally. Its light peaks in the blue-green, with less violet to begin with. So blue has a head start. Second, our eyes. We've got 3 kinds of cones: red, green, and blue sensitive. Notice what's missing? No violet-specific cone. Skylight reaching us is mostly scattered blue with a little violet. Blue cones fire strongly. Violet tickles red a tiny bit. The brain mixes the signals and we perceive blue. If we had bee-like eyes, more sensitive to ultraviolet, we might see a completely different sky. So our sky is blue because of the sun's output, the physics of Rayleigh scattering, and the biology of our eyes. How cool is that? White sunlight is many colors. Tiny molecules scatter short waves best. Our eyes read the result as that familiar sky blue, and the same physics paints rainbows, sunsets, and that pale horizon too. As the sun drops, its light travels through much more air, like taking the long way home through rush hour traffic. By the time it reaches you, most blue and violet are scattered away. What's left? The long wavelength reds, oranges, and yellows, the survivors of the long journey. Even at midday, the horizon often looks paler. Light from there travels through more air, so colors scatter and mix, washing out the deep blue. From an airplane on a clear day, look up. The sky turns a deeper, darker blue, even violet-tinged. At 35,000 feet, there's less atmosphere above you, so there's less scattering, revealing a deeper blue on the way to black space. Cloud droplets are much bigger than light waves. They don't play favorites. They scatter all colors about equally, so clouds look white. Storm clouds look dark on the bottom, not from dirt, but from shadow. The thick cloud blocks sunlight. From your seat, you witness it all. Deep blue, thin air, brilliant white cloud tops, and gray shadows below. Same sky, same sunlight, different scatterers, different looks. The more you look, the more the sky tells on itself. And if we left Earth, whole different stories. Our blue sky is unique to us, a signature of our specific atmosphere. Mars has a very thin, dusty atmosphere. By day, its sky can be faint butterscotch or pinkish red. Larger dust scatters longer red wavelengths. But at sunset on Mars, the sky near the sun turns blue, the opposite of Earth. On Venus, thick sulfuric clouds make an oppressive yellowish-white sky. On Jupiter, colors shift through layers: blues, whites, browns, reds. Our blue comes from a nitrogen-oxygen atmosphere, the sunlight our star produces, and the way our eyes interpret it. It's a daily reminder of how special and lucky we are. Next time you step outside, think about the 93 million mile trip that light took and the wild pinball game it played to paint that blue just for you. Keep looking up, stay curious, and never stop wondering about the magic happening right above your head. Under that big, beautiful Texas sky, now you know why it's blue.